So we changed, or we will change the program a little bit. So what we will do is we will focus only 2 slides more on the harvester, because we will see him after the breaks downstairs. Then a lot of things you could see on the slides, it's better to see him in real life. Then we have a small part on round balers and silage. And then we directly move to the ensiling process. So if you have a bunker silo, what are things you should be aware of? So that's the rough idea of the afternoon. And okay, so what you can see here, we will see downstairs, because they open up the harvester. That's very nice. Now, yeah. Sorry, he doesn't. Warum nimmt die jetzt nicht hier? Oh, okay. Takes a while. Yeah, one topic is the question cracking. Yes or no? Of course, it's a clear yes. And why is it a clear yes? Because if you want to use 100% of your potential, you have to crack the corn. And you have to crack them properly. We will see afterwards what are things I can check on the field. And the easiest one is you take 2 handfuls of silage, spread them on the table on the soil, and then count the corn kernels, if they are cracked or not. And if you find kernels which are not cracked, then, well, you should change your system. So why is it important? Because the question is always, can I get onto the nutritions inside? And of course, if I crack them, then they can easier move inside. And of course, you have a bigger outer surface, so they can grab. That's a little bit, you know, if you are standing in a room with 2 square meters, a small outer surface, probably you fit 6 people in there. If you have 10 or 20 square meters, more people can fit in, and that's the same with the bacteria. So the bacteria you need for digestibility, they need space, they need area to grab on, and therefore it's important. So you can see here, okay, so you have to make it available, you have to make it easy digestible. So that's one part of it. And of course, again, the compaction part. So it's really needed, and to be clear, it's a must that you do so. So that will be the short story on the corn cracker, because we will see it down there. No, come. Okay, and what we will continue with is the question of round balers, because they are normally connected to bale silage, and bale silage can be a real good alternative for producing a good silage, because normally the conditions are best, like in a tower silo, because you have a bale, you have, depending on the technique you use, a real good compaction, and the wrapping should be happen hopefully immediately. Again, as a number of sump, if you have one machine just baling and one machine just wrapping, the wrapping shouldn't be too late. So within 2 to 3 hours after baling. If the time is too long, again, you're losing money. So of course, then it might be easier to use a baler where these 2 steps are combined. So you have first the baling and then the wrapping. So we'll look a little bit through the balers, and just again to understand there are 3 different types of balers. They again have different principles, and again they have, due to that, a different impact on the quality of your silage. So they started with a constant baler, then they were into variable balers, and then they said, okay, we make a compromise between them, and that's the constant baler with a swivel element. So what's the idea? Okay, you have this constant baler, so you know the pickup, you put the material inside, and if you load this baler, it's a little bit like when you load your washing machine, you know? You put stuff in, and in the beginning, of course, there is hardly, for example, we take grass silage, there's hardly any grass inside, so there will be hardly any compaction, of course. The more gets in, like the more you put in your washing machine with clothes, the more dense it is, the more the material is compacted. So what's the simple outcome? If you have a bale with this kind of machine, the level of compaction is different. Point 1, point 2, inside the bale, the compaction is lowest. And of course, what you like to have is a high compaction, a homogeneous compaction, because then there is hardly any oxygen inside, and therefore the ensiling process will work. So therefore they said, okay, we have this constant baler, what can we do about it? And then of course they had the idea, okay, we make a variable baler. And you can see here again, so the stuff is getting in. You see here the band or the rollers. So you have a small room in the beginning. So you push your material in, and it's really already compacted because the room is small. And then, of course, you can set the pressure or the level of compaction. So when you are over the threshold, it opens up the room again. So hopefully you get a much more even compacted bale. That's one point. The second point is the bale inside is good compacted, so evenly distributed. And then even you might have a third benefit. The third benefit is you can adjust the size of the bale, of course, because you can stop when you have nearly 2 meters of diameter, or you probably stop when you only have 1 meter. Why is this important? Because you might think, okay, always the bigger the bale, the better. The better is the performance. But we will talk about it when we now go to this ensiling process. You have to think from the back. First, you have to know how much feed per day do I use. That's the important point. That's the starting point for all your calculations. Because when you open the bale, the process of losing money starts again. So normally it should be used within a day or even within 2 days. So if the bale is too big, it takes probably too much time, and then the bale is standing there and probably you feed, but parallel it's already rotting again or starting to rot. So you can control the size and try to meet your daily demands. So depending on the farm, especially if you have smaller farms or you're a contractor for different size of farms, that could be helpful. What is the disadvantage? Of course, the technique is much more complicated. Of course, therefore it's more expensive, but you have some of these benefits. And then, as I said, okay, wait, there's one extreme and the other extreme. Then they said, okay, we might make a hybrid system where you combine some of the advantages of the one system with the advantages of the other system. So they said, okay, we have this kind of swivel element here, so you can level it down. So the compaction process starts a bit earlier. It's not so evenly compacted with like a variable pressing chamber, but still is an improvement in combination to the constant chamber. So, and then of course, like I said, so the density is different. So the best distribution of density, to make the story short, you will get with a variable baler or variable baler chamber. And then probably a couple of points to the wrapping, because it's quite important. So the question is, yeah, do you have a two-in-one machine? I personally think in a lot of situations it makes sense, or especially if you're a contractor, because you drive there, you make the bale, you wrap it, and then you are done. And it doesn't matter what happens to the weather or the other machine breaks down. this bale is wrapped. Because otherwise, if you, for example, have two machines and the one is baling like hell and the wrapper has a problem, then the time of the bales standing outside before they're being wrapped is much too long. And again, you will lose money. So there could be some benefits of this combined machine. Then, of course, the question is, do I use a single bale or this kind of sausage baling? Back when they invented it in Europe, the idea was to save stretch film, because stretch film is expensive. And of course, if you have the sausage, you use less film. It works, of course, also very well, but you need a place to put the sausage. You need a place where to put the bale or the sausage. And for both, it's important there shouldn't be any stones or other things sticking out of the ground, because then you stick a hole in your bale and you will see the air can move into a bale between 30 to 1 meter. And then you can imagine if there is even a small hole in it, you ruin the whole bale. So that could be two ways of working with it. And then, of course, if you use the stretch film, you have to look if it's a good quality. That's one point. And the other point, it's always discussed with the farmers in Germany. Yeah, first, how to move them. Of course, you need special devices so that you don't destroy the stretch film. That should be logical. And then the question is how much wrapping is needed. And again, as a rule of thumb, normally at least 6 times of wrapping would make sense, because otherwise you might have regions where there is not enough overlapping, so oxygen can go into the bale. Again, you're losing money. And what happened in Germany recently is that they started a recycling program for the stretch film, so to keep the cost of the stretch film a little bit longer or lower, sorry, and to make it a little bit more sustainable. So these are also things you might have to think about, but otherwise it's a real good system. Okay, we will skip these slides. What's the composition of a stretch film? And here you can see the single ways of doing it. And just to give you an idea of a combined system, the question always is, how long does it take? We just and we stop here. So the bale is ready. So I skipped the first part. So it should it's supposed to be wrapped. And here you can see the time is running. So 4 seconds are already over. And then, of course, the bale goes in the wrapping unit. And then the wrapping starts. Like I say, hopefully 6 times or 6 wrappings, so that it's really as airtight as possible, so that it's the most efficient. And then you see the wrapping process now, it's roughly half of a minute. And you can see somewhere between half of a minute, 3/4 of a minute, everything is over, and you can transport the ball to what place, wherever you want. And again, this might be a good picture to see when there is no good overlapping, and then it looks like this. And it's white stuff, that's no snow in Germany, it's fungi. So you shouldn't, of course, avoid this, because it's easy to imagine this kind of silage you don't want to feed to your dairy. There is always a discussion about the color. Of course, the hotter the areas are, the more sunshine, the more it makes sense that you have a light color, because the easy story is bacteria is more working when the temperature is going up, and preheating means even when it's wrapped, you start an exchange of gases. So, of course, it makes more sense to have a light color for the bale. And yeah, just this one slide to see what sometimes are recent developments, also in Europe or Germany. You also think about stationary systems. So what do you move? You move the food with a loading wagon to the farm, and then you have a baler, or the combination. You have a big silo, and then you use this silage to produce small bales. That is also what's getting more and more popular. We already talked in the break about it. For example, that you have a big bunker silo, then produce small bales, for example, for horses, and people who have horses pay much more for your silage than people who have a dairy farm. Okay, and now we're coming to the part ensiling and silos. And to remind you, okay, what are the European conditions? Here the white stuff is really snow. You see there are different kinds or sizes of silos, of course. And this one here, that's a calf inside the snow heap. And you can imagine, depending where you are, you have up to 200 days where you need to have feed for your animals, because we only have one harvest and a long winter time. So that is one of the reasons why since decades we are working on it, because there is the strong need. Because if you don't have the food or the food quality, then you also will have the milk of the dairy cows. So that's the basic background. Okay, and then of course we have different parts of harvest, different parts of storage. And yeah, the corn cracker we already saw. And before we now start how to do it, I will just give you a brief idea about the ensiling process. So what's important? So you see, what's the idea? The pH should go down as fast as possible within a couple of days, because the sooner it goes down, the sooner the protein degradation stops or goes down, the respiration goes down. So that means if these both go down, you stop the losses or you minimize the losses. So therefore, of course, it's always interesting what to do, and what you need is a certain percent of carbohydrates, because these are the source when there is no oxygen that you produce this lactic acid, what is used to run the pH down. So that's the main point. And so if you run a dairy, you are just interested in lactic acid. So that's the goal. If you use it for a biogas plant, you also might have acetic acid, because the methane building potential is very high. So if you make a silage for a biogas plant or for a dairy, there are quite differences. But for a dairy, like I said, what you want to have is this lactic acid, and what you not want to have is this butyric acid. That's what you want to avoid. And therefore, what do you need? It has to be without oxygen, because the fermentation process only starts when there is hardly any oxygen left. So, and we already talked about it in the sessions before. What are the general recommendations? So there's the question of ideal harvest time, the ideal moisture content. It depends a little bit on the conditions. So therefore, probably that's not one-to-one transferable, but to give you again a number of thumb. And then I just want to show you this picture, not to confuse you, but just to show you that's the silage somewhere in the middle, and there are a lot of influencing factors. And my key message again is there are a lot of small screws you can use to minimize the losses. So don't look for one big one. No, you really have to see the whole picture. So that's the basic idea. And if you have a lack of, or if you have time, probably over Christmas, you can study it a bit more in detail. But the key message is there are a lot of factors, and you really have to be aware of the small ones. So, and where to plan? I already said we have to start from the end. So you have to know what amount of feed or amount of nutrition, to be honest, so quantity and quality, does my dairy use per day? Because that's the basic figure for all the rest of the calculation. So how much silage do I use with a certain nutrition content? That's the first thing to know or to estimate. Because then you know what you need per day. Then you estimate what might be your post-harvest losses, because post-harvest loss means if you have this 100% of corn on the field, till it goes into your silo, you already have losses. So you won't get this 100% or nearly, you won't make it. So to get the 100% into your silo. So first you already have to subtrate this, so that you know, okay, from this, let's say 100%, 95% go into the silo, and how much other losses do I have to see what do I need. And the losses are high. And most of the people don't believe them, but if you measure them, you know, and you can see, depending where you are, how you do it, so 25% is already not too bad. But if you really look on farms, and also German farms, the average is higher. A lot of them had 30% losses. That means 30% of the money you put in your product, the corn, is lost. It also means you need 1/3 of more area to produce the same amount of food. So it's very important to realize it's really your money what's gone if you don't take this into account. So what I like to say, or what I already said, okay, is you have to know what's the intake or withdrawal, the daily intake into the stable, so the daily withdrawal out of my silo. And here you see different kinds of silos, so small bags. That's the bigger one in Germany. That's from a kind of family farm in Germany. And so again, what is one key factor, especially under your conditions, you really have to remember and you need for the calculation. So when you, for example, open a new silo and the silo starts here, then the key question is, if you have the intake of the first day, how much do you move into the silo? And how much do you move into the silo over 1 week? And the rule of thumb, again, is very, very roughly, it should be at least more than 0.5 meter per day. And so when I start here on day 1, and after 1 week, 1, 2, 3, 4, I should be somewhere here. Why is this important? Because as soon as you open the silo, the process of re-fermenting and restarting of losses will start again. So if you have a small intake, the silage will already start to rot inside your silo because the oxygen is already going in, and you get preheating and pre-fermentation processes you don't want to have. So therefore, if you now try to calculate the size of your silo, you have to know, okay, how much food per day do I use, and what will be the size of the cross-section if I, within 1 week, have to move in 3 to 4 meters. So that's the basic numbers, very easy to calculate the size of your silo. If you don't do so, you will lose money. And if you now look, we see there are different ways of doing working with a silo. So the main question is, are there support walls, yes or no? What you can imagine, even especially when you see this silo, the compaction of the sides will be very challenging, because I wouldn't like to be the one who's driving this tractor, you know, trying to compact these edges here. So normally you would rather recommend a silo with supporting walls. And now coming back to the dimensions, so we already have an idea of what might be the cross-section. but you still can play with the width of the silo and the height of the silo, because the cross-section is just that you, for example, say I need 10 or 15 square meters so that I have this withdrawal what is needed. And so the question is, what is the optimal width of a silo? Where to start? And what you can see here is when you see this tractor and he tries to compact, and even if he drives with his wheels very close to this wall, he nearly can compact the middle part. Therefore, there is always a minimum width, and that should be around, hopefully, rather 4.5 meters. So it's wide enough, and of course, it depends a little bit how wide is your tractor, of course, but that you really can compact the whole area in the whole silo. So there is always a minimum width. And if you know the other numbers, then you can calculate, okay, how high can my silo, or should it be? What else is important? If you have supporting walls, also easy to see. So if we would say, okay, here that's the supporting walls of this silo, and they are straight, and I want to compact it here, then I have really to skid around the wall to compact the edges, because the difficult parts are the edges. So if you don't have a wall like this, if you have a small angle, then of course it's much easier to compact the walls without destroying your concrete. Because this silo should not last for 5 years, it should last a little bit longer. So therefore, if you have supporting walls, it makes sense to use them like this. And what you already can see, so if you, of course, only have a silo plate and the silo is not so high, then it's also not too difficult to compact the sides, but still, it's not really optimal. And again, yeah, here you see a little bit of the compaction process, or what I said. First, the idea is small levels, then a compaction tractor or compaction device on it. And of course, the larger the silos are, it makes sense that probably you said, okay, the silo or the width of the silo is as big that, for example, 2 or 3 tractors can work parallel. So probably one unloading, one trying to get it evenly distributed, and one compacting. So that really depends a little bit in the end of the size. So you have to multiply the width that you know, okay, all these devices can run parallel within the silo. And what you already can see here, because that's what you like to avoid, these kind of black parts, here you also can see it, because the, let's say, compaction on the top is always the difficult thing, and of course on the sides, and here it rather looks the way like it is supposed to be. And then there is the question, okay, you need these concrete walls. What do you have to be aware of the concrete? And there are, again, 2 things. First is the quality of the concrete. And please don't underestimate this topic. Because the normal idea is, I need a concrete wall, so I need you look for my local concrete provider, and then I'm done. What you have to realize is, you have different qualities of concrete, and if you have a bad quality of concrete, water can go through the concrete, and gas and oxygen can go to the concrete. So you don't think if I have a concrete wall, it doesn't matter what I do, it's airtight and it's watertight. You don't have if you have a poor quality of concrete. So be please aware of that. That's one part. And the second part, of course, is about the concrete. What's about the building cost? How can I make it a little bit cheaper? And one idea is, of course, that you say, okay, how to observe the forces on the walls by the silage and by the compacting tractor. And one way doing this, you have this kind of earth walls, and you see, you just have very slim concrete walls. because the pressure is buffered by the earth wall. So that's a very typical system to keep the concrete cost a little bit down, so you can use this earth wall systems. And here you could see that would be a typical size, so 5 to 6 meters wide, so 2 machines can work parallel, and you have the certain angle, so really you'll be able to do the compaction on the sides very properly. And here again, yes, so you have an overview on the different ways of doing it. Here with the walls with a certain angle, with the supporting earth wall inside. Just, this one would just be a plate, a silo plate, because in Germany at least, you're not allowed to put a silo on a normal ground due to the pollution into the earth, but you shouldn't do it anyway because moisture and also gas exchange would go into your silage from underneath, and it wouldn't be good for that. So that would be typical ways of doing it. And again, so to try to sum up again, dimensions of the silo. So you need to know what's the daily intake. You need to know, okay, my goal is withdrawal or intake under your conditions 4 to 5 meters per week. What will be the width and the height of this silo? And the other question, of course, is what is the length? And if you have just a small silo, then of course it should be so long enough that one loader wagon can be up or downloaded in one way. So because then you have to just drive one way, you have this metering rollers, you get your nice layer, and then you can move out again. So that makes sense. And of course, you should have a kind of a slope inside and a gutter at the end, because you have silage effluent always a little bit, so fluid material from the silo. And of course, it shouldn't stay inside the silo, and there should be a separate tank to store it. And if you have a biogas plant, then you have the beneficial situation that you can use the effluent in your biogas plant, because the methane production potential of this effluent is quite high. So in this case, you don't waste it, you don't spread it on the field, you just put it into your biogas plant. And therefore, when you have this typical German silo, so you can see the slope, you have the storage for the effluent, and you have the gutter so that it can just flow inside. So that's the rough idea. And yeah, we already talked about this, so if I have too much sand or soil inside, it doesn't make sense. Here again, you see another graph of the question, high and low raw ash content. So high raw ash content means you probably had a height only of 3 or 4 centimeters. And what is a very interesting number is this butyric acid. It's compared to the ideal situation very high. And the problem for dairy cows is it's not tasty, it's very smelly, so they wouldn't like to eat it. And when we go down to the chopper, one topic is the shopping length. So the theoretically shopping length of your forage. And what is the general idea about it? So, of course, you have big particles, coarse particles, and smalls. The more big particles you have, the more gaps you have where there is oxygen in. And you don't want to have the oxygen, because the idea of the compaction is to get the oxygen out of your silage. If you have smaller particles, of course, the gaps are smaller, but there is a certain limit, because the smaller they are, the more fuel consumption you have in your harvester. That's one part. And the other part, that would be a part for our colleagues from the animal nutrition. There should be a certain length so that it's still good food for dairy cows. So there is a limit, of course. And when we come to the part, how can I check it on the field? So if you have a lot of dusty parts inside, then you really have a problem, because the very small parts, they should be always less 10%. That's again a rule of thumb. If they are higher than 10%, they on one hand never make it to the dairy cow, and of course also the fermentation process is not so good. So what you want is a good combination of small and big particles is one part, and the relationship of these particles to each other should stay the same. So that's again something to check if you check what's your harvester doing, so that the particle distribution doesn't change suddenly in a very big way. So in general, they should stay on a certain level so that the level is always equal, and then the compaction is much easier to do. And then there is even one more point, what's even more complicated to measure. Up to now also we didn't have a good solution to measure it. So if you have a particle and you have two particles the same size, if these two particles have the same size, that still does not mean that the outer surface, and this rectangle should reflect the outer surface, is the same, because depending how what kind of harvester you have, what kind of corn cracking operations and so on, you might have one where you have a much bigger outer surface, and that means it's much better to ensil, it's much better to ferment, it's much better to digest by the animals. So that's also one topic just to be aware, so that you need this bigger outer surface. And again, that's also one of the things you check. So if you look on your sample, that you say, okay, are the stems are broken, are the corns are broken? Because if the less they are broken, the smaller is the outer surface, and therefore they are not as good to ferment and to digest. So and that is what I already told you in summary or on the slide. So if you afterwards want on the slide, and the slides are available after the seminar for everybody. So we already talked about the question of the corn cracking, yes or no, so we can skip this. And there are always recommendations for the theoretically chopping length. This would be some under German conditions, so you can't take them one-to-one. So that really is dependent on what animals do you have, how does your feed looks, how does your TMR looks like, so you can play a little bit with it. But it only should show you that it makes sense to think about it and always have it in a certain range. So that's the key message of this picture. And now we come to the, let's call it simple method. So what could I do or can I do if I like to check? And I already told you it is important always to check in a regular time frame, to check how the silage looks like, or the chopped corn, to be honest. And I just want to mention 3 different tests. So there's the 1 liter test, the water test, and the pan-stained shaking box. What I like most is this kind of 1 liter test. You see there's this nice glass bucket you can buy for a small price to get 1 liter of corn. But you also can take, of course, 2 handfuls of corn and spread them on the soil, spread them on the table. So you get the material. You hopefully get it from a representative spot, and then you just look at it. And what are the criteria? Again, rule of thumb. There should not be more than two kernels which are not quite broken. And then for the rest, you have to see, is it processed equally? So, are there stem pieces where the outer skin is not rubbed off? Yes or no? Are there pieces which are not split? When are there the more pieces are in which are not split, where the outer surface is not rubbed up, the more you have of them, the more difficult is the ensiling process. And so that's quite important. And of course, it's also important in the end for the dairy cow, because you have this fiber digesting microorganisms in the rumen. So if it's already a bit processed, it's much easier for them to work. That means in the end, you have a higher milk yield. And then there's another part. The question is, do you have varying lengths or overlengths? So pieces which are too long. And again, now you have to look into the stable. And what you might realize is cows are very selective and very tasty. A lot of people don't believe, but if you look at them, if you watch them, you know. But that's what you not want. You probably feed them a TMR, and the idea is it's ideally mixed, and they should get exactly this mix, because that's what you calculated from the nutrition basis. So they shouldn't select, select a little bit from here, select a little bit from there, because then they don't get, or not all the animals get the nutrition content, what it's supposed to be for them the best. So you enlarge the selecting process when there are pieces which are too long. And these are all things you can already check on the field. And then, of course, like I said before, so the different lengths should be, in a way, constant. So if you take more samples over the day, and then, of course, you can make it a bit more sophisticated. We have a look on the shaking box. And so these are already the important parts to know. And now I have a picture. I hope you can see it, probably not as good because it's a bit light. So that would be a test. And then when you start counting, here's a full kernel, here's a full kernel, there's a full kernel, there's a full kernel. There are two kernels not crushed. So the easy judgment would be that's no good, to make the story short. And these are things you easily can check, or the person on the harvester, or the person who checks the silage going into the process. Other test is the water test. This you can use just to see the difference between the small and the light particles. We will skip this. The most sophisticated, let's call it like this, test is the Penn State shaking box. What's the idea? You have different boxes with different sieve holes. So you put the material in, you start shaking the box, and then after a while, after enough shaking, you take these elements and weigh what's the amount of food in each box. And you can see they have different pore sizes from, that's an inch, from 0.7 inch to 2.16 inch, so different particle sizes. And what you already can see, so the bottom part are the very, very small ones, and as a rule of thumb, there the idea should be less than 10%. And the others, these are values for US conditions. These are things you really have to adapt to your conditions. For example, if you look on the same results in Germany, the recommendations of the percentages are a little bit different than the ones you see here. So you have to remember, don't take these numbers 1-to-1. That is one of the parts you and your animal nutritionists have to figure out what's the best under your conditions. But where you are running in general, you can already see with this box. So yeah, here's how you calculate it. We can skip that. So if you try again to sum up, what are the important things? What did we already talk about? What you can check, what everybody can check. Are there kernels which are still intact? Then you already have a problem. So they should at least quartered. In Germany, even because 10 years ago you would say chopped is all right. Nowadays they are already going direction milled or grinded. I don't know. I personally would say kernels with at least quartered, that's the main part. We already heard the residual of the plants shouldn't be not too long, because then the animal will start to select. And there is also an interesting part, because normally you say, okay, the shorter the shopping length, the better will be my yield. A little bit like with the grass, that's not really the true story. So roughly what's recommended, roughly 25 centimeters, even probably a little bit more when you have a very hilly area and you have a combine with a very big working width, then it even can make sense to make more, because that way you keep the intake of dirt as low as possible. And probably you remember, dirt means raw ash content, and raw ash content already means 10 to 15% less of potential of your silage. And then the interesting part is, the higher the shop, the higher is the energy density. This again can have a positive effect on the taste of your ration, and that of course might be not unimportant. Do the animals really like to eat it? Because like I said, they're very selective. Okay, right at the moment I'm asking myself, when will we make a break? Probably in 10 minutes. Okay, yeah, wonderful. Because in 10 minutes we will do the compaction of the lecture and also the topic of compaction. So, as I said, here you heard it so many times, you know, compaction is a key factor, and all the surrounding conditions that you can realize it. What are influencing factors? Of course, the optimal distribution we already talked about. The weight of the device, of course, the heavier the device, the better is the compaction. The time period of compaction, and that's the very crucial part. If you have this compaction device, it should drive slow, because the slower you drive, the more effective is your compaction. Again, as a rule of thumb, you shouldn't drive faster than 3 to 4 kilometers per hour. So really slow, that you really are able to use the weight of the machine to do the compaction. Then the frequency of repeated compactions, again as a rule of thumb, at least 3 to 4 times over every spot. So that should, if the length of the silage is all right, should be okay. And then you also have to realize, also when it's totally filled up, that you also compact the surface again, because you can test it by yourself. You cut grass, put it in your hand, you try to compact it, and when you open your hand again, then it moves up, you know, it relaxes. That will happen also here. So the compaction of the surface when it's ready is important. Therefore, there are farmers, they say, okay, I have 3 devices on my silo. One is the distribution, one is the compaction on the sides, and one is the compaction on the top, you know. Why? And now we come to next very important requirement, because the question, how long should it take till the silo is filled up. Because if you put the silage in there and all the time it's not airtight, you start processes you don't want to have, so you have losses. So the goal is to do it within 2 to 3 days. That is the goal. If you are able to fill it in between 2 days would be ideal. If it's more than 5 days, you're already losing money because it's getting airtight too late. And then, of course, what you also need is this process of dynamic shearing. What does it mean? When you see this distribution here, and just by compaction, the small ones won't move in the holes of the big ones. So there also is some shearing process. Normally, the tires of the tractors compacting it are enough for it. But therefore, again, it is important that the level you put in is not so high, because these shearing processes are can work much better when you only have 30 meters of layer to be compacted. And yeah, here you see some devices. That will be a typical device behind the tractor just to put more weight on it. And also, these are rollers with pins on them so that you, let's say, stress a little bit or improve a little bit this shearing process. And that's the way, yeah, how it should look like. And in the break, I saw a nice video where it looked exactly like this. And then you're in business. And this slide again is the summary. So discharge with metering rollers, good distribution, not too thick. Heavy tractor, high tire pressure. The higher the tire pressure, the more you can improve your compaction with the same weight of the tractor. So it's just the other way around than on arable land. So high pressure in the tire. And then, of course, there's always idea, is my device heavy enough? Yes or no? And again, to make a rough calculation, you can calculate the harvesting output in tons per dry matter per hour, divide it by 3 or 4, and then you get a rough idea what should be the weight of the tractor compacting it, just to get an idea. And we already talked about the velocity and also at least, again, to do the compaction when the silo is really filled. So I think what now became quite clear is who's the bottleneck in the whole system. You might have a nice harvester, but the real bottleneck could be transport, but normally it's a compaction. That's the bottleneck. But that is the most important part. But normally, you know, if the harvester is running, you have a contractor, you see the money running, you know, you're paying for the harvester. So you say, yeah, the compaction might be ready already, you know, because otherwise the harvester must stop. But to be quite clear, it's better to save the money really to stop the harvester. He gets a break. You don't have to pay the fuel and do the compaction and not the other way around. Of course, for the person on the compaction tractor, that's probably a bit of a stressing situation. But what you really, as key message, have to realize is give these guys time enough to do their job. Because otherwise, the money you lose by the losses are much higher. Because if you don't do it proper and you have more losses of 20, 30%, then 20 or 30% of your money is gone. Or you need 20 to 30% more of fields to get the same amount you can feed to your dairy cows. You have to really keep that in your mind. So please let the ones who do the compaction, give them their time. And nowadays, within the idea of digitalization, the company already thinks to automate it, you know. The compaction tractor tells the harvester how to drive, what should be the performance right now, so that the amount being harvested and the amount being compacted really fits to each other. And that's quite important. And I hope I stressed this far enough now. So these are recommendations for compaction. What you can see is also here the rough number. It's kilogram per dry matter per square meter. And you don't have to read all the numbers. The rough idea is it has to be over 200. Then you are going more in direction what makes sense. And just to get an idea, why is this important? Here you can see different dry matter losses depending just on the compaction. That was a result from laboratory. And you can see if you compare this or this very high compaction to this one, already only dry matter losses of 10% might be the result of it. But yeah, here we have the tower CI-LO. We will skip this. But what you realize is the problem is also the oxygen going into the silage due to the less compaction, and of course, when you open it. So here you already saw these pictures. Here probably it's hard to see. There's already a very dark layer inside. That means at that time the compaction driver didn't do his job properly, and so you have, and that's the worst thing you can happen. In the middle of your silo, you have a part what is not really good compacted because it will rotten to the top and rotten to the bottom. So you will ideally destroy your own silage. And here you have a picture, that's the concrete, poor quality. You see that's a wet surface. So just water, humidity is going in, and you can see this black part here already. So it's moving in from the outside. And here you have a low compacted silage against a good compacted silage. You see the picture of a thermal camera. You can easily see the temperatures here are much higher, nearly 10 degrees higher than on the other side. So of course you get preheating. Preheating means losses. So that shows you hopefully quite clear why it is so important to do this kind of compaction. And again, also when you open the silo, oxygen can move into the silo. I already told you. The silo starts to degrade again, or the forage. The more it is compacted, the more time you will have for aerobic stability. What does it mean? That means, okay, if it's really compacted and airtight, and you take it out, a silage, put it on the table, you can wait for 6 days, and it will start to degrade after 6 days. If it's poor compacted, you can put it on the table, and it already starts after 3 days. Again, one of the reasons why a lot of intake, so this 5 meters per week, and why to be quick enough at that time. And it also shows you, okay, when you open it up, the question is, does it rather looks like this? So has it a lot of outer surface? Of course, also then the danger of losing material will be much higher. Okay, we are coming close to 2 o'clock. And here also, just that you get an idea, that's the penetration, you know, how much gets the oxygen inside the silage just by opening it. Poor compaction, 1 meter, it's going in there. We already talked about. I think the numbers talk for themselves. Yeah, we also already saw this, bad overlapping, doesn't look good. And then, of course, if you did the compaction good, then the last point is getting it airtight. You can see it here. So you need airtight silage. That's very important. And if you have a poor concrete, that it even makes sense to have kind of a wall film just to prevent oxygen or water going in from the outside into the silage. And I think because we only have 5 slides left, probably we will make till 2:05, because then we are done with this topic. If it's okay, the organizers say it's okay. Okay. So you have to put the silo film on it. It has to be airtight. Here you can see a German farmer. He is very happy because it's airtight. And he has a good forage for his cows. And there will be only 2 slides left before we come to the slide to the take-home message I already showed you at the beginning. So we talked the whole day about losses. There are unavoidable losses, you can't avoid, and avoidable losses. And you see, so yes, respiration, unavoidable, normally maximum 2%. Fermentation, unavoidable, 10%. So if everything works all right, you already lose between 5 to 10%. Then there might be silage effluent. If you have a biogas plant, you don't have to worry. If you have a dairy, you might worry, depending on if there is a lot effluent, yes or no. You have field losses, we talked about it. You have fault fermentation. You have aerobic spoilage, that means you open it and too much air can get in. And then, of course, you have preheating. So, and then you can start adding up those numbers to see what are my actual losses. And to make the picture full, and that's the last slide with numbers, don't worry. So you have to realize, if I now look on the whole picture, you have losses due to harvest, loading, transport, somewhere between 2 to 50. Let's say you're working good 2%, but they're realistic. Losses due to silage making, from 5 to 30. To be honest, I never have a silo seen in Germany, at least, what has less than 10%. So normal way is rather 20 to 30. So then you have losses to silo taking. That's again 10%. So if you sum them up, 10% to reach is, even under laboratory conditions, nearly not possible. But over 50% is not unnormal. And so that's the last number. That again will show you, if you lose 50% of what you produced before, then you're a bad businessman. And therefore we come to the conclusions. That was what I showed you in the beginning. That's the take-home message. So what you really have to see, you'll have to look on the whole process. You have to see all the small screws. You have all to keep the small screws in your eyes to reduce your losses probably only to 20%. And then you would be even on a very good side. So I hope this take-home message did settle. So thank you very much, and thank you for giving me 5 additional minutes so we could close up this topic. Thank you very much for listening. Yeah, so we will have a break for how long? 50 minutes, so 2:20. So you can use the break, already move to the machines, and then Lucas will have his part. He will show you around so that you can see a little bit in real life what we talked about. So yeah, enjoy your break, and then we will see each other roughly 2:20, right?
ให้เลยค่ะเป็นของขวัญ
ถ้าแบบมีทางเลือกคือถ้ามันไม่พอเนี่ยก็เติมแลคติกแอซิดก็ได้หรือว่าเติมไอกากกับน้ำตาลไปเพื่อให้เกิดการหมักให้เกิด
โดยปกติก็ไม่ใส่
ปกติเขาไม่ใส่ที่เราไม่เติม
test 1 2 3
ครับ
Yeah, so, but did he also try it without?
บ้านเราก็ลองแบบไม่ใส่เหมือนกันเนาะมีใช่ไหม
โดยปกติก็ไม่ใส่เพียงแต่ว่าพอเขาทำในส่วนของการพัฒนาการใช้จุลินทรีย์เขาก็